Pleasant day, everyone, especially to our instructor in S108, Dr. Vivian Cabalbal Pelegro. By the way, I am Goldamer Grace Tingaglungay, taking Bachelor of Secondary Education, major in Science, third year college from Section A, and I am the third reporter for the Chapter 3. So last meeting, Ms. Gerald Lucetta discussed about the ultrasound wave. So today I will be the one to discuss my topic. But before that, I will sing to you a song first. So just listen carefully because after this, I will ask questions. One. Kayandang siyang hatas itinura mo, piling niya ihatak hindi parinig mo. Kay kung ikaw mo ang magpaabot, kami iyang ihatak kanimo. Dili pa panahon, bulag ko sa puhon, ikaw sa parin at tandaan. Sa tuwing magpahilom, sa may buong dahon, sa mga mawalang na. Kasakit ko ang tay, tunay tinignan. Ako na lang kapit, ako na lang kapit, ako na lang kapit. So, based on what you have heard, class, what do you think is our lesson for today? So, yes, as I plucked the guitar, you heard a sound, and because you heard a sound, today it has the connection of my report. So, the topic that I will discuss for today is all about the reflection and refraction of sound waves. But before that, let me present to you first the objective of my discussion. So at the end of the lesson, the students are expected to first define reflection and refraction of sound waves. Second is perform a laboratory on how sound waves moves in matter. And the last one is describe what is echo and what are the conditions to be heard. Okay, again, my topic is all about reflection and refraction of sound. Before that, let us first tackle first the performance that I gave it to you. So, based on my performance, how does the guitar sound? How does the guitar produce a sound waves? So, anyone? So, by plucking the string of the guitar, it has the capability to produce a sound waves. So, by plucking the string of the guitar, we can able to produce a sound waves if you pluck the string of the guitar. So why can we hear a sound? So it is because energy from the guitar, it travels as sound waves to your ears. That's why you can hear a sound. So another is how does the motion of a drummer's drumstick produce a sound waves? So the impact of the sticks on the head of a drum causes the drum head to vibrate. So this vibration transfer energy to nearby air particles, producing sound waves in air. So you can hear a sound again because of the energy from the drum that travels as sound waves to your ears. Again, you can hear the sound because energy from the drum travels as sound waves to your ear. So every sound you hear is caused by something vibrating. So next, another example is when you sing, like I present lately. So I used to sing, or example is when you talk. So tissues in your throat vibrates in different ways to form a sound. So when you try to speak or try to sing, the tissues of your throat can able to produce or form a sound because of the vibration. So now, did you know that the sound waves are compressional waves? So, like for example, is a vibrating drum head produce a sound waves. So the drum head produces a compression. So each time it moves upward, the refraction upward. So and refraction each time it moves downwards. So next, different So now I will show to you the speed of sound in different materials. So the materials are the air, glass, steel, water, seawater, rubber, and the diamond, and also the iron. So the speed of the air is 343, the glass is 5,640, and the steel is 5,940, and so on. So now um, in solid liquid gas, which of the three where sound waves travel faster? So anyone? So yes. Sound waves, sound travels more quickly through solid than through liquid and gas. Why? It is because the molecules of a solid are closer together and therefore can transmit the vibration energy faster. Okay, next slide. So now, um, which part of our body is a complex organ that can detect a wide range of sounds? So the part of our body which is can detect a wide range of our can detect a wide range of sound. It is our ear. So now let us know what are the different parts of the ear where hearing is very important. So first is the outer ear. The definition of it is the outer ear is the sound collector. So it consists of the parts that can see and that we can see, which is this is the outer ear and the ear canal. So next is the second part of the hearing in the ear is the middle ear. So the middle ear is the sound amplifier. It consists of eardrum and three tiny bones called the hammer, the anvil, and the stirrup. As you can see in the picture, the you can see that there the in middle ear there is hammer anvil in the stirrup. So sound waves can pass through ear canal because of the eardrum to vibrate. So this vibration are transmitted to the three small bones which amplifying the vibration. So the last one is the inner ear. So the inner ear contains cochlea. So the cochlea, which filled with fluid and is linked with the tiny hair-like cells, so vibrations of the stirrup bones are transmitted to their hair cells. So the movement of the hair cells produce signals that travels to your brain, where they are interpreted as sound. So that are the three parts of the ear, which is again the outer ear, the inner ear, and the middle ear. So next slide. So since my topic is all about reflection and refraction of sound, let us first tackle what is reflection of sound waves. So next, so what is the definition of reflection of sound waves? So reflection of sound waves is the bouncing back of sound waves from the surface is called reflection of sound, or we can say that when sound travels in a given medium, it strikes the surface to another medium so that it returns in some other direction. So this phenomenon is called reflection of sound. So next slide. So what do you need? Let us um, compare first the reflection of the sound and the reflection of the light. So what do you need for reflecting of for the reflection of light? So what we need is what do you see is the mirror. Second is the um, that is the that is a surface where um, so now so now let us now let us compare first the reflection of the sound and the reflection of the light. So let us first know what do we need for reflection of light. So what do we need for the reflection of light? So first, as you can see, that is a mirror. Next is a polished surface. So what about the wall, the table and chairs, and even you and me? Are we a good reflectors of light? So the answer is yes. It is because that's how we see the world around us. So it's through reflected light from the objects. Next is since we are done what we need to for the reflection of light, now is what do you need for a reflection of surface? So anyone? Okay, any surface can reflect. Why? It is because sound can reflect in any surface. That is why um, every one of us, so now is since my report is all about reflection and refraction of sound, let us first tackle the reflection of sound waves. What is reflection of sound waves? So reflection of sound waves, it is the bouncing back of the sound waves from the surface. It is called reflection of sound, or we can say that when sound travels in a given medium, it strikes the surface of another medium so that it returns in some other direction. So this phenomenon is called reflection of sound. Now, let us compare first the reflection of light and the reflection of sound. So first is what do you need to know or what do you need for reflection of light? So anyone? So as you can see, the first picture is mirror. So mirror is one that we need for the reflection of light. Second is the polished surface. So how about the walls? No, the walls, the tables and the chairs, and even you and me. Are we a good reflectors of light? So the answer is yes, we are a good reflector of light. It is because that's how we see the world around us. It's through reflected light from the object. So next slide. So what do you need for a reflection of sound? So what you need for a reflection of sound is any surface can reflect sound. Again, what you need for reflection of sound is any surface can reflect sound. Another is compare your curtain and your wall in your home. My question is, which of the two are better conductor? Is it the wall or your wall or the your curtain in your home? So the answer would be the best reflector of sound. It is the wall. Yes, why? Because wall typically large and hard surface are better reflectors of sound. And one of the example of that is the wall in your home. So again, large and hard surface are better reflectors of light, of sound rather. So, did you know that reflection of sound and the reflection of light, they obey the law of reflection? So, what is the law of reflection? It is the angle of incident where equal to the angle of reflection. So, as you can see in the image or the picture in the screen, so the angle of incident there is equal to the angle of the reflection. So the incident ray and the reflected ray and the normal are all in the same plane. So they are equal. Again, the reflection of the light and reflection of sound, they obey the law of reflection. So did you know that there are two main phenomena in reflection of sound? So since we already compared the light and the sound, so let us focus on the reflection of sound. So reflection of sound, there are two main phenomena. So in reflection of sound, so they are echo and the reverberation. So let us talk of first the echo. So what is echo? Echo is a reflection of sound that arrives at the listener with a delay after the direct sound. So it occurs when a pulse of sound can be heard. So in echo, there is a time gap. There is a time gap that you can hear. So it is two or more distinct sounds. Like for example, in hearing an echo, I know that every one of you is already hear what is echo. So it sounds like, for example, hello, hello, hello. So again, there is a time gap that you can hear echo. It is two or more distinct sounds. So now let us look echo in detail. So try to say hello in this room or in your room. So did you hear any echoes? Okay. You cannot hear echoes because your room is small. So now let's imagine that you are in a mountain or a hill and you got there to shout hello. So it will sounds like hello, hello, hello. So you will hear multiple echoes in big space like hills or mountains where it can reflect sounds. So let us understand that how big space it will help us to hear multiple echoes. To simplify, let's imagine this place that, or let's imagine this place that this is a hill or a mountain where we can shout hello. So the first hello is almost instantaneous. So since the sound traveling from your mouth to your ears, so the ear needs a minimum time gap of zero point 0.1 seconds to distinguish between the first hello and the second hello. Again, there is a minimum time gap when you hear an echo, it is 0.1 second. So, so that's how the large distance helps to hear echoes between you and the hill. So again, you can hear multiple echoes when you are in a big space like hills or mountains. So now, why second hello is softer than the first hello? So it is because the hill absorbs some sound energy. So now, how we can calculate the minimum distance to hear an echo? Next slide. So, in calculating the minimum distance to hear echo, so the formula is again the minimum time gap in hearing an echo is 0.1 seconds. So, the formula in calculating the minimum distance to hear the echo is distance is equal to speed times 5. So, since we hear two echoes in our example, which is hello, hello. So the distance of the minimum time gap is 0.1 seconds. So it is 343 meters per second because that is the material that we use is air. So what are we going to do is multiply the speed and the time. So the value of the speed is 343 meters per second and the time is 0.1 seconds. If you multiply it, it will result 34.3 meters. So to get the distance, you should divide 2d divided by 2, and also if you try to multiply the distance, you should also multiply the other 1, which is 34.3 meters divided by 2. It is equal to 17.15 meters. So 2 divided by 2 is 1. That's why only the D there is left. So distance is equal to the distance that we hear in when we try to hear the echoes in the mountain is 17.15 meter. So since we are done in echo, let us tackle the other phenomenon of the reflection of sound, which is the reverberation. So what is reverberation? So it is the persistence of sounds after the sound source has been stopped. So it results from a large number of reflected waves which can be perceived by the brain as a continuous sound. So there is a continuity of the sound, and that is called, again, the persistence of sounds. So it happens due to the overlap of the multiple sound. So reverberation sounds like hello, hello. Sounds like that. So in reverberation, again, there is a persistence of sound. So you might hear this when you try to speak in the large hall. So like auditorium or large dome. And this place, there are multiple reflections of sounds which can cause this reflected sound to overlap the original one. So typically, this reflection needs to be heard within 0.05 seconds only. That is the time gap that we can hear the reflection or the reverberation. So for you to hear the reverberation effect, so it's half of the echo value, which is the 0.1 seconds, that leads us to persistence of sounds, which causes reverberation. So that is the reflection of sound waves. The two Again, the two phenomenon of the reflection of sound waves are the echoes and the reverberation. Now let us move to the second topic, which is the reflection of sound waves. So what is reflection of sound waves? So reflection of sound waves is the refraction of waves involves a change in the direction of waves as they pass from one medium to another. So it is the blending or spreading out if sound waves from the other medium to another. So sound waves travels from air at the higher temperature to lower temperature. So during daytime, sounds travels faster at Earth's surface since the air molecules are hotter due to the energy absorbed from the Earth ground. So the air molecules at the higher altitude are cooler than those at the Earth's surface, as you can see in the picture, causing sound waves to refract upward. So rest assured that sound travels faster in the warm air than the cool air. So and let me give you some evidence of that when I was in high school in joining the Boy Scout. So I I observed that during daytime it is harder for us to listen to those people who are away from us. We cannot hear it clearly. Then I was very curious when at daytime why my co scouter didn't hear me clearly in daytime. And as I we are going to sleep, we are trying to go to sleep. I can hear clearly those voices that I heard, and I was asking myself, why is it um, we can hear the we can hear them clearly at night than daytime? Um, the it is because the sound travel faster in the warm air than the cool air. That is why we can hear this sound at the we can hear this sound clearly at nighttime. It is because of the refraction of the sound waves, which is the bending or the spreading out of the sound. Again, we can hear clearly in nighttime or nighttime than daytime because of the refraction of the sound waves and the blending of the sound. So that is my report for today. Thank you so much for listening.